Hello, you friends. Okay, we're going back to March 9th, which I think was our last week in school together, is when we were talking about concentration. So here's a couple glasses of lemonade right here. This is a glass of lemonade right here, and this is a glass of lemonade right here. You can kind of tell that this one's yellower than this one, which means this one's more concentrated in about the same volume of solution. This solution has more lemon juice in it, more sugar in it than this one does. This one's more concentrated. So when we're moving forward here and we're talking about acids and bases, we're going to be talking about concentration a lot, which is how much acid or how much base is in those different amounts of solution. So we have to use numbers, which is no big deal. So this is what we left off with right here. Let me hide this sucker. Boom. Okay, so intro to solution chemistry. What we said is that a solution is a something dissolved in a something. You guys remember what those somethings were? I'll give you a hint. They both start with S. A solution is a solute dissolved in a solvent. That's right. And if you want to quantify the concentration of a solution, you simply have to divide the amount of one of these by the amount of the other one. You have to divide the amount of solute by the amount of not solvent. You have to divide by the amount of solution. And you can put any number in here you want and any number in here you want. You could put grams over 100 milliliters. You could put milliliters over milliliters, whatever. But what we're going to use most often is moles per liter. And the reason we do that is because that way we can compare apples to apples. If we're comparing, let's say, a solution of sodium chloride to a solution of sodium nitrate, sodium chloride and sodium nitrate molecules weigh different amounts, but this accounts for that right here. If you're using moles per liter, you're talking about the number of molecules per liter. And it doesn't matter how big each molecule is, you're talking about the same number. So molarity is equal to the moles of solute, that's the chemical that's dissolved in there, divided by how many liters of solution you have. And it's symbolized with a big M for molarity. So note, big M does not mean moles, it means moles per liter or molarity. That's right. So in all molarity problems, it's always going to look like this. You're always going to have your moles of solute divided by your liters of solution, and that's always going to equal your molarity. And in every problem I give you guys, you're going to know two of these, and you're going to have to solve for the third one. You might know these two and have to solve for this one. You might know these two and have to solve for this one. You might know these two and have to solve for this one. So that's the trick. You'll always know two of these numbers. These boxes represent numbers. You'll always know two of them, and you're going to have to solve for the third one. Okay. BT dubs, if you guys have these notes, this was on page 196 of your notebook right here. And on page 195 here, there's a bunch of practice problems that you guys may have already done. So there's three types of molarity problems. Here's one type. How many grams of sodium chloride would you need to make 300 milliliters of 0.5 molar sodium chloride? I'm going to read that one more time. How many grams of sodium chloride would you need to make 300 milliliters of 0.5 molar sodium chloride? So once again, you're going to know two of these numbers and have to solve for the third one. It looks like we're going to have to solve for how many grams. And you'll notice here that there's no grams anywhere in there. Yeah? Well, grams, we can use the periodic table, which we did earlier in the week, to translate between grams and moles. This is how we translate between grams and moles. So if we know how many moles, we know how many grams. So it looks like we got 300 milliliters of solution. So 300 milliliters is equal to 0.3 liters. We just have to move that decimal over 1, 2, 3 spots. So it's 3/10 of a liter, 300 milliliters, because a liter is 1,000 milliliters. So it looks like the molarity of this solution is 0.5 molar. So what we're going to do is we're going to put X right here. X divided by 0.3 equals 0.5. So we're going to have to multiply both sides by 0.3, and that's going to cancel out 0.3. So X is equal to 5/10 times 3/10, which is 15/100. 15/100 moles of sodium chloride. But the question asks for how many grams, because the thing is our scales can't measure how many moles of sodium chloride you have. Our scales in the lab, our balances, measure how many grams you have. So we need to translate this into grams. So we're going to go like this. We're going to do times. We're going to have to figure out how many grams there are in a mole of sodium chloride. So I go here to sodium, and the sodium atoms weigh 22.99 grams per mole, plus chloride atoms weigh 35.45 grams per mole. So that's 58.44 grams per mole. 58.44 grams per 1 mole of sodium chloride. And then moles of sodium chloride, goner. So I just have to take this 58.44 and multiply it by 15/100 times 0.15 equals 8.77. 8.77, and what are my units? Grams of sodium chloride. So how many grams of sodium chloride would you need to make 300 milliliters of 5/10 molar sodium chloride? You'd need 8.77 grams. You are going to be asked to do that in the lab at some point, and that's how you're going to figure that out. How's that sound? Okay, the other ones, that's the hardest one right there. I gave that to you guys first so I could go all the way through it. These next two, I'm not going to go all the way through, just in the interest of saving a little bit of time here. So if a 2 molar solution of sodium chloride contained 3 grams of sodium chloride, what would its volume be? So we know that this is the number that we don't know, because it's asking what would its volume be. So if we don't know that we know this, and we know this. So it says it has 3 grams of sodium chloride. So I'm going to have to take 3 grams and turn that into moles and put it right here, just like we did earlier in the week. And then if the concentration is 2 molar, 2.0 molar, then that goes right there. So once I have that number and that number, I can use algebra to solve for that number, and that's going to be the volume of the solution in liters, of course. Third type of problem. So in the first type of problem, we pardon me. In the first type of problem, we needed to solve for moles of sodium chloride so that we could get grams of sodium chloride. You guys can't see that too good, can you? Moles of sodium chloride, so we could figure out the grams of sodium chloride. In the second one, we needed to figure out what the volume is. Sorry, we need to figure out what the volume is. In this third one, it says, what is the molar concentration? So we know that it's asking what is the molar concentration. So that's what we're going to solve for over there. So what's the molar concentration of 530 mils of solution that contains 1/10 of a gram of sodium chloride? So once again, we're going to need to turn that 1/10 of a gram into moles. So 1/10 of a gram of sodium chloride times 1 mole of sodium chloride per, how many grams in a mole of sodium chloride again? Oh yeah, 58.44. 58.44 grams of sodium chloride. And then grams of sodium chloride, that's going to cancel out. So we're just going to do 1/10 divided by 58.44. 1/10 divided by 58.44 equals 0.0017 moles of sodium chloride. So that number is going to go up here. 0.0017 moles of sodium chloride in how much solution? 530 milliliters. But I can't put 530 in here because I don't want milliliters. I would need liters. So that would be 0.530 liters. So I would just take this number here, 0.0017 0.0017 divided by 0.53 equals 0.0032 liters. I'm sorry, 0.0032 molar sodium chloride. So that's not a super high concentration of sodium chloride, but we might need a really small concentration of sodium chloride to conduct a reaction. So anywho, that's the 3 methods which we can solve these problems. And I know that this video was a lot for today. So I'm actually going to give you guys 3 practice problems to do tomorrow. That's it for today. Watching this video, taking some sweet notes. You can use your sweet notes to do some sweet practice problems tomorrow. I'll give you 3 practice problems. I'm going to give you 3 similar to these, but I'm not going to put them in the same order. So you're going to have to figure out which type of problem is asking for which thing. I miss you guys a bunch, and I hope you're doing okay. And I guess I'll see you guys sooner, maybe next fall, eh? Okay, bye.